Hello and welcome. This is our lecture on atomic mass. Go ahead, put today's date and the lecture number at the top of your notes. So atomic mass, simply put, is the weight of a single atom. And it's the number that we see on our periodic table. And every single periodic table square, we'll see this number, which typically has a long decimal expansion. That part right there is the atomic mass. So the units for atomic mass are called AMUs, and that stands for atomic mass unit. And an AMU is approximately equal to the weight of one proton. Now it's important to remember that protons are approximately equal to neutrons in weight. So the atomic mass unit is approximately how many protons and neutrons the atom has. Now there's also another unit that's identical to an AMU, but it's a little bit older. It's called a Dalton. It's equal to an AMU, and sometimes we see the abbreviation capital D little a. These are all the same thing. Now, if we want to put it into grams, it would be about 1.6 times 10 to the negative 24th grams. This is a 0 with 23 more zeros before we get to the 1. So 0.23 zeros, then we get to the 1. So obviously doing math with such tiny numbers is really difficult because even in scientific notation, this takes a while to say. So that's why we scale everything to the weight of one proton as we come up with our unit. An important thing to note about atomic mass is that it is the average weight when we take into account all of the different isotopes of a specific element. So two very common isotopes for silver are silver 107 and silver 109. Silver 107, if I had a pure sample of silver 107, I could calculate that it has an atomic mass of about 107 AMUs, and silver 109 is about 109 AMUs. But on the periodic table, we see a number that's in between 107 and 109. We get 107.86. So this number here is an average that takes into account the different isotopes. And it actually weights these different masses by their relative abundance. If we dug up a bunch of silver out of the Earth's crust, some of it would be silver 107, some of it would be 109, and that ratio is pretty standardized across all silver on Earth. And we can assume if we find just a random sample that it's going to have that same ratio of isotopes, and that this atomic mass will help us calculate a lot of different things about our silver, how pure it is, how much of it we have, and other things. So even though the atomic mass is just an average, it gives us a clue about what the most common isotopes of an atom might be. Here we see osmium has an atomic mass of 190.23. This tells us that the most common isotope is around 190. Now let's look at the relative abundances of osmium. We can see some of the lighter isotopes are very rare, like osmium 184, but the most abundant is osmium 192, which is very close to 190. So if we don't know anything else about osmium, we can at least take a guess at what its most common isotope is based off of this atomic mass. You just round it to the nearest integer. I want to point one other thing out that's interesting about atomic mass, and that's that it's often a little bit lighter than you would think. If we know that a proton is about equal to a neutron, and each of those is equal to an AMU, it's kind of strange that neon 20 here, which has 20 protons / neutrons, has an atomic mass of 19.992. So it's a little bit low. Well, what's happening here is that to hold the protons in the nucleus of neon, that actually takes energy. It takes some binding energy because all these positive charges are repelling one another and they want to just leave the nucleus, but they're bound together with some energy. Well, where did that energy come from? It came from E equals mc squared, Einstein's famous equation, which swapped out a little bit of the mass of those protons and neutrons for a little bit of energy to bind them together. So I think that's interesting that we see an artifact of that in the isotopic weights of our atoms. All right, we'll call that good for this lecture video. I'll embed a few more questions for you to answer here, and have a good rest of your day.